This video discusses partial correlation. We have just calculated the correlation between the variables x and y, and now we want to know the partial correlation between x and y whilst controlling for the effect of variable z. This means that we want to know the correlation between x and y when we keep z constant, and we can calculate this by using the following formula. We want to know the correlation between x and y whilst controlling for the effect of variable z. We do the following calculation: the correlation between x and y minus the correlation between x and z multiplied by the correlation between y and z. We then divide this by the square root of 1 minus the correlation between x and z squared multiplied by 1 minus the correlation between y and z squared. And we therefore need the correlation between x and y, between x and z, and between y and z. In the denominator, we need the correlations between x and z and between y and z as well. We're going to calculate this by means of an example. We have the variable x with the values 1, 2, 3, 4, 5. We have variable y with the variables with the values 6, 11, 7, 8, and 13. And now we also have variable z, which has the values 8, 3, 9, 7, and 5. We've calculated the correlation between x and y already, which equals 0.6. Correlation between x and z is also given, which equals minus 0.13. We could ask that of r. And then the correlation between y and z, which equals minus 0.82. So first we're going to calculate the numerator. The correlation between x and y is 0.6. Correlation between x and z is minus 0.13, and the correlation between y and z is minus 0.82. The numerator therefore equals 0.6 minus negative 0.13 multiplied by negative 0.82. And if we elaborate on this calculation, we see that minus 0.13 multiplied by minus 0.82 is equal to 0.11. So we then calculate 0.6 minus 0.11, which is equal to 0.49. Now we're going to calculate the denominator. And this is equal to the square root of 1 minus the correlation between x and z squared multiplied by 1 minus the correlation between y and z squared. To calculate the denominator, we calculate the square root of 1 minus negative 0.13 squared multiplied by 1 minus negative 0.82 squared. 1 minus negative 0.13 squared is equal to 0.98, and 1 minus negative 0.82 squared is equal to 0.33. 0.98 multiplied by 0.33 is equal to 0.32, so we have to calculate the square root of 0.32, which is equal to 0.57. To calculate the partial correlation, we divide 0.49 by 0.57, and this equals 0.86. In conclusion, this is the partial correlation between x and y whilst controlling for the effect of z.